So now that we've looked at the basics, which is that we can solve when our ratio is one of our special triangles, and then again, you'll always get two answers. We can solve when it's a quadrantal angle, and there'll be one answer or two answers depending. And then we've also looked at when it's outside of our range, in which case there's no answers. And then when we get these weird decimal ones that we're just going to touch a calculator. And now we're going to apply what we've learned there and add one step beyond, which is that we are going to solve with factoring. So you're going to be given a question like the 2 times sine squared x minus 1 equals 0. And again, we're going to try to solve for x. So you're going to think of solving this algebraically again. We're going to add 1. We get 2 sine squared x equals 1. And then we're going to divide by 2. I get sine squared x is equal to a half. Now again, we're trying to get all the way into this x, so the next thing we're going to do is take a square root. The key thing is, don't forget, when you take a square root, it's always a plus minus. So we are solving where sine x equals plus or minus the square root of 1, which is 1, over the square root of 2. Now I don't need to rationalize this because I'm not giving this as a final answer. I'm looking for what values of x would give me the ratio of 1 root 2. Hopefully you're thinking of your 1 root 2. So we're going to go step number 1. Right? Well, I guess step number 1 is isolate your trig function. Step number 2 is that we are going to use our cast rule. Now, sine is positive in quadrants 1 and 2. But we also want to solve where sine is negative, which is quadrants 3 and 4. So we are just going to give our answers in all 4 quadrants. If the opposite is 1 and the hypotenuse is root 2, that's going to make this my 1, root 2 triangle, which is going to make my reference angle pi by 4. So what answers do I get? Well, I get an answer in quadrant 1, which would just be pi by 4. I get an answer in quadrant 2, and don't feel like you have to show this work. Like if you're okay figuring out what the answers would be without showing work, you don't have to show it. But I'm doing this for people who sometimes forget. So the quadrant 2, it's pi minus the reference angle, so pi minus pi by 4, which would give you 4 pi by 4 minus pi by 4, which is 3 pi by 4. In quadrant 3, it's going to be pi plus pi by 4. Right, because it's pi by 4 past pi, which is going to be 4 pi by 4 plus pi by 4, which is 5 pi by 4. I hate it when the 4s look like 9s, which is going to give me 5 pi by 4. And then lastly, in quadrant 4, it would be 2 pi minus pi by 4. And 2 pi with a denominator of 4 is 8 pi by 4 minus pi by 4, which is going to give me 7 pi by 4. So again, you don't have to show the answers like that. You could just go, hey, the solution set is pi by 4, 3 pi by 4, 5 pi by 4, a lot of answers, and 7 pi by 4. Awesome. Okay, why don't you pause the video and give this one a go. So this one's a similar idea. We're going to add 4. So we're going to get secant squared x is equal to 4. Then we're going to take the square root. So we get secant x is equal to plus or minus the square root of 4, which means that the secant of x is equal to plus or minus 2. Now, you are more than welcome to keep it as secant if you can think of it as hypotenuse over adjacent. But if you can't, change it to cos. If the secant x equals plus or minus 2, then the cos of x is going to equal plus or minus a half. Then you have to think, is this one of my special triangles? So 1 root 2, 1 2 root 3. Heck yes. Because it's plus or minus, it can be in all 4 quadrants. Oh, it's so fun to draw a bow tie. There we go. My adjacent is 1, my hypotenuse is 2, that makes it the 1 2 root 3 triangle, which makes my reference angle pi by 3. So again, my answer in quadrant 1 would be pi by 3. My answer in quadrant 2 would be pi minus pi by 3, or 3 pi by 3 minus pi by 3, which is 2 pi by 3. In quadrant 3, it would be pi plus pi by 3, or 3 pi by 3 plus pi by 3, which is 4 pi by 3. And then lastly, in quadrant 4, it would be 2 pi minus pi by 3. Oh, I'm getting a hand cramp. Which writing 2 pi by 3 with a denominator of 3 would be 6 pi by 3 minus pi by 3, which would be 5 pi by 3. And again, if you write them like that, I'm totally fine with it. Or you can be like, hey, you know what? My solutions are pi by 3, 2 pi by 3, 4 pi by 3, and 5 pi by 3. Awesome. Okay, so that's number one. It said solve by factoring, which we didn't factor. We actually kept solving algebraically. But I think of these as solving when there's something funky with the solution. So these ones we solved using the square root method. Maybe I should have said solving quadratics, but they're not all quadratic. Anyway, whatever. Square root. The next ones we're going to do are truly factoring. So if you look at this one, we have a cos squared, a cos, and a number. So hopefully you guys are thinking of a trinomial. What does that mean? Well, you can think of it as 2u squared plus 3u minus 2, right? And you could solve it like this, thinking AC method, or if you're okay with the word cos being there, we're still going to do AC method. So we're going to do 2 times negative 2 is negative 4. We're looking for two numbers that multiply to get me negative 4 and add to give me 3. I should stop making videos. I am tired. Which are 4 and negative 1. So we'd write 2 cos squared x plus 4 cos x minus 1 cos x minus 2. Then we're going to factor by grouping. Out of the first group, I'm going to pull out a 2 cos x to be left with cos x plus 2. Out of the second group, there's nothing I can take out, but I always take the sign of the first term. So I'm going to take out a minus 1, and I'm left with cos x plus 2. Then I'm going to greatest common factor out of these two terms. I'm going to take out a cos x plus 2, and I'm left with 2 cos x minus 1. If you're someone who hates factoring, don't forget you could use the quadratic formula. What it would be is that cos x equals, and then you could do negative b plus or minus the square root of b squared minus 4ac all over 2a, or you could make it u equals, where u is equal to cos x. You know, you've got so many options using what we've learned in this course and maybe previous courses, but I will tell you that 100% of the questions in 7.5 are factorable. They don't put ones in where you would have to use the quadratic formula. I'm just saying that you can if you want. All right, so zero factor property, we set it equal to 0, we factored, now we're going to set each factor equal to 0 to solve. So we've got cos x plus 2 equals 0, which would make cos x equal to negative 2. And then we've got 2 cos x minus 1 equals 0, which would make 2 cos x equal to 1, which would make cos x equal to a half. Now let's start with this guy. Cos x is equal to negative 2. That is not in the restricted range. So there is no solution for this side. But cos x equal to a half, we do. So we're going to think C, A, S, T. I can get a solution in quadrant 1 and quadrant 4. If my adjacent is 1 and my hypotenuse is 2, it's my 1, 2, root 3 triangle, which makes my reference angle pi by 3. So my values of x would be pi by 3 in quadrant 1, and then in quadrant 4 it's 6 pi by 3, which is 2 pi, minus pi by 3, which gives me my other answer of 5 pi by 3. I'm going to start showing less steps. All right. It's a big one. All right, and again, don't forget you can always plug these in, right? You could do 60 if you don't want to type pi by 3 and just plug in 60 degrees. Make sure your calculator's in degrees and make sure that it's equal to 0. This next one I see wrong all the time. The number one mistake I see people do is they're like, hey, look, there's cos x on each side. Let's divide both sides by cos x. I'm like, well, technically, yes, you are allowed to do that. The problem is that gets rid of a solution. Like if you think of x squared minus 7x, if I was to divide everything by x, the x would go away and I'd lose part of my solution. I should have x times x minus 7, and I get x equals 0 and x equals 7. So don't ever divide by something that has an x in it. Instead, we're going to think of factoring. So now you're probably thinking, what can I do? You can do is think of it as solving by factoring. To solve by factoring, you're thinking of the zero factor property. In other words, you're going to make it equal to 0. So I'm going to minus cos x from each side, and that's going to leave me with sine x cos x minus cos x equals 0. And now I'm going to factor. Now the factoring I'm going to do is greatest common factoring, so I'm going to take a cos x out. I would be left with sine x minus 1. And then I'm going to solve my factors. So what would make cos x equal to 0? And what would make sine x minus 1 equal to 0? Well, let's start with this guy first. Where does cos x equal to 0? Cos follows x, so you can think of it as 0, 1, or 0, negative 1, or you can think of your cos graph, right? So if I was to graph a cos graph from 0 to 2 pi, it crosses at my first key point, or I guess my second key point, right? 1, 2, 3. Yeah, 1, 2, 3, 4. I was trying to count my key points. So it's going to happen at my second and my fourth key point. So either way, x is going to equal pi by 2 and 3 pi by 2. Where for this one, we've got sine x is equal to 1. And again, sine follows y. So my y value is 1 up here. So x would equal pi by 2. So I did get that answer of pi by 2 twice. So if I was going to, and I'm fine if you leave your answer like this, but if I was going to declare an answer, I don't have to write it twice. I would just say the answers are pi by 2 and 3 pi by 2. All right, so that is solving by factoring. So again, if you look at the assignment sheet, we're in solving with factoring, and you're going to do these questions, but only do from 0 to 2 pi. So your textbook says 0 to 2 pi and 0 to 360, but we're just going to focus on radians.